We're going to try some chemistry paper 1 revision today, guys. So we're going to try some exam questions. We've got a Kahoot coming up as well in about half an hour. So I want to try and get through a bit of revision before then. Teach you guys a few things on Chem paper 1. And you guys can ask me questions, ask me for tips. And yeah, hopefully I can help you guys out. So let me know if you guys got any questions. How's everyone doing? Can you hear me okay? Can you guys let me know if you can hear me okay? Let me know in the comments. And we can get started. Yeah, good stuff, good stuff. Thank you guys. Hi Ninda, how are you doing? How was biology? How do you guys find the biology paper 1? So yeah, I thought we would go through these questions from a paper that I've got. You guys just let me know what you guys think of the what the answers are. So for the first one here, what order did scientists use to arrange elements in the early periodic tables? Incredible bio paper, says Daisy. That's good. That's good. That's good. They didn't know about protons, neutrons, and electrons. Yeah, they hadn't been discovered. So we had to use something called atomic weight, which is basically like a much simpler way of measuring the masses of different elements. This is an AQA paper, but a lot of it is relevant to OCR Gateway. There's so much overlap between those two things. Thank you for the rose, Dr. Azam. Thank you. Next up, table. Mendeleev did this by leaving what? This question comes up all the time. Gaps. Olivia, thank you very much. Answer here is gaps. So what he did, unlike other scientists who forced elements into different groups, he did something different. If he found that the properties didn't match up, he left gaps there because he basically predicted that those elements hadn't been discovered at that point in time, instead of forcing groups into that. So he based them strictly on the properties, and then after that, what happened was people discovered those elements and they did fit his predictions. So he made predictions about those elements in the gaps, and he guys, noble gases, nice one. Okay, this one, we've got an atom of argon represented. That top number is 4018. Let me write it here properly. We've got 40 and 18. Determine the number of protons and the number of neutrons in an atom of argon. Easy. If you want the number of protons, it's right there in front of you. It's always the bottom number. The bottom number is the atomic number. That tells you the number of protons. So the answer here is 18. Number of neutrons. If you want to work out the number of neutrons, you subtract the bottom number from the top number. So we'll do 40 minus 18 to give 20, given to these different types of atoms. So you can see here the bottom number is the same. They're the same element. Bottom number, i.e. the atomic number, is the same, but the mass number is different. We've got 39 at the top. So remember, the top number tells you the number of neutrons plus protons. Bottom number tells you the number of protons, which you can say is the number of electrons because they should be equal. Overall charge of an atom needs to be neutral, isn't it? So what is the a name given to these? These are called isotopes. Yes, definition of an isotope, guys. Elements or atoms of an element with the same number of protons but a different number of neutrons. Electrons here. Electrons, number of electrons is equal to the number of protons in a neutral atom. So we can just use the atomic number here, the bottom number 18. So we've got 18 electrons here. So if we've got 18 electrons, we need to split that into our electron shells. So first of all, thank you, Olivia. 2 goes into the first one. That gets filled up. So then it moves to the next one, which has 8. That gets filled up. And that's all. Is argon unreactive? Next question. Why is argon unreactive? What do you guys think the answer here is? It's got a full outer shell. Yes. Full outer shell, exactly. What does a full outer shell do, guys? Does anyone know? What does that do? It has a full outer shell, so it's stable. Thank you very much. Yes, so its structure is stable. Amazing. You guys are smashing it, smashing it. So yeah, definitely. It doesn't lose or gain electrons because of that. Okay? That's what makes it inert. Leon says, can we do the Kahoot? Yep, we will. I'll do it in about 20 minutes. 9:15. I'll do it. Sodium reacts with chlorine to produce sodium chloride. Balance this equation, guys. So we want the same number of elements in here. Right now, we've got 1 sodium, we've got 2 chlorines. On the other side, we've got 1 sodium and we've got 1 chlorine. We want to make this have 2 chlorines to make it balanced, because on the left hand side we've got 2 chlorines. So we'll get rid of that 1 and we'll add a 2 here to make that a 2. But the issue with that is if you put a 2 in front of NaCl, you're also doubling the number of sodiums in there. So that also becomes 2. So now we have our chlorines balanced, but we don't have our sodiums balanced. So we need to balance our sodiums. All we need to do is put a 2 here and it's balanced there. 2, 2. Well done, guys. Smashing it. What is the mass of chlorine reactive? Does anyone know what to do here? I'm going to rub out all of this stuff here. So calculation, chemistry calculations. I know you guys, I know loads of people don't like chemistry calculations. My opinion, chemistry paper 1, hardest science. What do you guys think? Do you guys agree with that? Chemistry paper 1 is the hardest science paper in GCSEs. Agree or disagree? What do you guys think the hardest one is? You take away, exactly. Let me put those balancing numbers back. 2 and 2. So let's, Olivia says physics paper 1 is harder. Layla doesn't agree either. What do you guys think? Physics is harder. You don't need to do mole calculations here. Physics paper 2. Yeah, magnetism is pretty hard, right? Magnetism is pretty hard. But I do think physics paper 1 is harder than physics paper 2 though. No, sorry. Chemistry paper 1 is harder than chemistry paper 2. I do think that. Okay, so what you need to do here is the conservation of mass, okay? Conservation of mass states the mass on the right-hand side of the equation needs to equal the mass on the left-hand side of the equation, because 11.7 grams on the right. So that means you need 11.7 grams on the left as well. So 4.6 plus something should equal 11.7. How do we work that something out? 11.7 minus 4.6 grams is going to give you the answer. We've got 7.1. Someone's got 7.1. Amazing. You guys are doing well. Yeah, Kahoot. Let's see how we're looking on that. How many people we got? That's a tiny screen. Let me make that screen a bit bigger. 8 people. 8 people. We can get people join it. Okay, cool. 15 minutes, guys. So answer here is 7.1 grams. A teacher puts hot sodium is a something solid. What do you think the correct answer here is? How do you recognize that it's a conservation of mass and not when to use moles? Because they've given you the mass of 2 of them and there's only 1 left to find. If in a mole calculation, there'll be more unknowns. It'll be a more complicated reaction. It'll be Na plus CO2 goes to NaCl plus something else. And then they'll only give you 1 and they'll ask you to find another. Here, they've given us 2 masses and the only one left is here. So we can use the conservation of mass. The mass before should always equal the mass after. But in mole calculations, they don't give you enough information to do that. That's how you know it's a mole calculation and not a conservation of mass question. Silver. Silver, silver, silver. Sodium is a silver solid. Yes, it is. It's just like any other metal. It's silver. Chlorine. What color is chlorine? You guys need to know the colors of chlorine, bromine, and iodine. You need to know the states, and you need to know the colors of all three of those. Chlorine is not yellow. No, loads of people think it's yellow. Let's see if the mark scheme accepts yellow though. It accepts yellow. Fine. Yeah, you can say yellow, but the actual color is green. It does accept yellow. The hot sodium burns with a something flame. This is a bit of a cheeky question because this is more of a paper 2. Fluorine, that's right. Someone asked, is yellow fluorine? Yes, it is. Sodium does not burn with a lilac flame. Does anyone know what lilac flame is? It's not sodium. It's something else. Lilac flame. What burns with a lilac flame? Who knows? Potassium. Well done, Priv. Potassium burns with a lilac flame. The product sodium chloride is a something solid. What do you guys think that something is? Something solid. Sodium chloride is basically white. Yes, it's salt. Sodium chloride is salt. It's literally salt that you put in your chips. It's white. It's a white solid. You need to memorize that. Good stuff. Sodium chloride is an ionic compound. Write down the formula of the ions in sodium chloride. So here it's +1. Anything in group 2 is +2. Anything in group 3 is +3. 4 and 5 you don't need to know for GCSEs. Even group 3, no, yeah, they can ask you because they asked for aluminium. Next after that is group 6. Group 6 has a charge of -2. Group 7 has a charge of -1. Okay, so try and memorize that. And then all you need is a periodic table. So remember, they give you a periodic table in chemistry. They don't give you an equation sheet like they do in physics. So you use the periodic table, go to sodium, find out where sodium is. Sodium is in group 1. That must mean it's +1. So it's Na+. And then chlorine is in group 7. So that's minus. So we can just write that as Cl-. We don't need a 2 in front. And for triple as well. Potassium is more reactive than sodium. This is because potassium loses something more easily. Answer here is an electron, okay? Anything to do with the reaction is usually transfer of electron. How does the size of a potassium atom compare with the size of a sodium atom? So if you look in the periodic table, you'll find in group 1, you would find sodium first. No, not sodium first, I lie. So lithium, then sodium, then potassium. What's after potassium? Is it rubidium? Don't memorize it off the top of my head. But yeah, potassium is lower down. So why is the size of potassium? What can we say? So sodium has more shells, Amelia. Nope, that's not right. How long will the Kahoot last? It's about 19 questions, this one. 19 questions. Sodium is smaller. Yeah, exactly. Potassium is bigger. So potassium is larger. We need to say why. It has more shells, exactly. Don't say it has more outer shell. 2 shell, the bigger it gets. 3 shells. Yeah? So potassium is larger. It has more. 4, 5, 661. 661. Okay, next question. This is called a reaction profile. A reaction profile shows you how energy changes throughout a reaction. Okay, so on the y-axis, you've got energy. On the x-axis, you've got progress of reaction. You've got the reactants here, and then you've got the products here. And in the middle here, you've always got a hump in it. Okay, all of these reactions have a hump in it. It asks you to label the activation energy. Activation energy is always from the reactants to the peak. Reactants to the peak. Okay, so let's draw a dotted line here. You'd get a ruler and draw an upward arrow this way. That is the activation energy. It basically is the minimum amount of energy required for a successful collision to take place within the reactants. Okay, so your reactants are moving around. They need to collide with a high enough energy in order to react. Activation energy is the minimum amount of energy required for that. From a left line, arrow to the top, yeah, exactly. Between the peak of the curve, yep, excellent, excellent. Does it have to be a dotted? No, you don't need to draw the dotted line. You don't need to draw the dotted line. You lost a mark because I didn't draw the arrow on the line when labeling. Okay, so I'm looking at the mark scheme right now. I'll now tell you if you get a mark or not. It says ignore arrowheads on the mark. It doesn't matter which way around you do it. So some people do two-ended arrows like that. It's technically not right, but if you were to draw that, you should still get the marks. This is a higher paper. Yeah. Is this exothermic? Asks Hash. What do you guys think? It's exo. Yes, it's exo. Okay, so if it goes from a high level to a low level, a high energy to a low energy, it means energy is given off. All of this energy in the middle, the energy change, that's the energy that's given off to the surroundings. This is an exothermic reaction. Just an extra piece of information for you guys. Exothermic reaction. What's the Kahoot code? Can you guys see it up there? It's above. It's above my head on the stream. Determine the overall energy change for this reaction between the hydrogen and oxygen shown in part A. Okay, so usually you don't actually need to use numbers, but you can see here they've given you a scale. That means we need to use this scale. Label the activation energy. You need to be able to overall energy change is from the reactants to the products. So I'm going to draw a dotted line here because it's going to make our calculations easier. So this downward arrow. Okay, and it's asking us to calculate what it is. So what you need to do, so activation energy, it decreases. No, you don't say activation energy decreases. Energy decreases. Activation energy is always this upward arrow. So when the product line is less or below, then it's exothermic. Yeah. So how do we know it's exothermic? You know it's exothermic, guys, when the products are lower than the reactants. If the products are higher than the reactants, it's endothermic. Make sense? Let me know, guys. So if we want to actually find out what the energy change is, you want to read off the numbers from the graph. Here and here. What do you guys think? What's that number? What's that number? You guys getting it? Yeah. Looks like people are understanding this, so that's good. Top one's 800 exactly. Bottom 800 and 300. 500 kilojoules. All right. Covalent bonding. Two ways you can do this. You can either memorize the oxygen one. There's like a set of ones you need to memorize. You can find them on the spec, or you can follow this method. We're doing the Kahoot in about 3 minutes. 3 minutes. And then what I'll do is I'll come back to these questions after if you guys want to do a bit more revision. So when you're trying to draw one of these, what sooner than 3 minutes? Very soon. Let me finish this question off and we'll see. So what you do, you look at oxygen in the periodic table, see how many electrons it's got. Oxygen is in group 6, okay? That means it's got 6 electrons in its outer shells. You only need to draw the outer shell electrons when it comes to covalent bonding. So that means we've got 6 on the left, 1, 2, 3, 4, 5, 6 that we need to put somewhere. And then we've got 6 on the right. Okay, so what needs to go in your head? is, let's first look at this left oxygen. It has 6 electrons. How many does it need to get a 4 outer shell? It needs 8 in total, right? So it needs 2 more. So what it needs is it needs 2 electrons from here. It needs to share 2 electrons. So we're going to get these 2 electrons and we're going to put it in the sharing region in the middle here. Okay, so let me cross these 2 out and I'm going to put them in the middle. 1, 2. And we're going to do the same with the right hand side. We have 6 electrons here. How many do we need to get a 4 outer shell? Again, we need 2. Where is it going to get the 2 electrons from? It's going to get it from this oxygen. So let's do the same thing. Let's get these 2 crosses and put it in the middle here. 1, 2. Now, whatever's left over, you just put 1, 2, 3, 4. We've used 2, 3, 4, 5, 6, 7. Right. This method works for any diagram with yeah, it works with any diagram. There's a single bond, so this is a double. But if it's in the morning, then this probably be the last one. All right, it's 9:15, guys. Let's get this Kahoot started. It's in the morning. Yeah, sorry. What I'll do is I'll stay after the Kahoot as well, and I'll carry on with these questions after, guys. So stay behind if you want to do some more revision. Let me give you guys a chance to join the Kahoot now. How many people we've got? We've got 31 people in here. I'm going to wait 2 more minutes for people to join. Guys, working hard on that. 37. Keep joining, guys. So we've got, how many questions? We've got, I think, 19. So it's not a quick one. I'll try and get through them quite quickly, though. $47. Wow, a lot of people joined. Week in the middle. I've got a half term to make this video. So yes, that's the plan. Was to do that. I can't have that, and I'll be saying other things. Green lobster. Cause trouble. 63 people in. How long should I wait? Is there anyone else trying to join? Shall I wait another minute? Oh, anyone? Yeah, top 3, guys, is the usual thing. If you're top 3, we will get a session. I did it for bio. I'm going to do another one for Chem. So if you're in the top 3 here, you guys will get free access to that, as well as all the other ones. It's on our okay, good luck, guys. We've got 70 people in here. Literally in these questions. All it tells you the number of electrons. Then we've got the mass number at the top. Okay, well done, guys. You didn't even get to answer. Leon, you've been waiting since the beginning. What do you mean you didn't get to answer? Everyone was telling me to start. I got pressured into it. Silver Fox, well done. Who's that? Is there anyone in the chat here as well? Question 2 of 17. What is the term for a mixture of metals? If you have loads of different metals, what do we call those? Loads of different metals. Great, yak. Okay. Nice. Answer is an alloy here. Loads of different ones are called that, isn't it? Well done, well done. Leon, unlucky. Try and get some right. You can work your way up. Go to the next one. Plenty of questions. Which of these is a diatomic molecule? Does anyone know my memory trick to how to remember all the diatomic molecules you need to know for GCSEs? Who knows? Who knows? Anyone know in the chat? Very simple if you want to memorize them. Priv, that's another way. Yeah, never have fear of ice cold beer. That's another one. Or you look for anything that ends with GEN at the end: hydrogen, oxygen, nitrogen, and halogens, or the halogens, or the group 7. So those are all the ones you need to know: hydrogen, nitrogen, oxygen, and halogen, group 7s. Yeah. Gens, stranger. Yes, you got it. Lucky Wombats moved up to top place. Golden Soth and Great Yaks dropped down to third. These questions are going to get harder, guys. These are warm-ups. Hopefully. Look at this. This is phosphorus. Top number is 31. Bottom number is 15. Slide. Yep, guys, you can still join. We still got plenty of questions left. You have to submit, yes. Subtract the two numbers. You do LXL, that's still fine. IGCSEs, most of these questions are relevant to you guys, by the way. Don't worry. Nice. So remember, electrons were discovered by Rutherford. True or false? Were electrons discovered by Rutherford? So there's 5 different scientists you need to know, isn't it? 5 different scientists. You need to know what they discovered. False. Who discovered electrons? Who knows the answer? It's J.J. Thomson. Yes, it is. J.J. Thomson discovered electrons. Rutherford discovered. I mean, that's biology. To the next one. What do elements in the same group share? So what do they have? Same number of shells, same atomic weight, same number of outer electrons, same size. What's the answer here? What do you guys think? Hello. Same outer electron. Okay, so the group number, from the group number you can tell what the number of outer electrons in an element is. Okay, so if it's group 5, it means it has 5 electrons on its outer shell. Same top 3, guys. If you just joined us, you can, and then I'll do some questions after this. On to the next question. Type. What is the name of the following? Slowly revealing itself. What is this? Type it if you know what it is. Be careful. I'm seeing the mistake. Many layers. Graphene is only 1 layer. Okay. 30 of you got that right. Well done to the 30 of you who got it right. Graphene is 1. Okay, so graphene is 1 layer, graphite is multiple layers. Eager Elk and Amazon Otter Justin. Question 8 of 17. What are the group 1 elements known as? Transition metals. People would put that accidentally. Earth metals. No, not alkali earth metals. Alkali earth metals is actually group 2, but you don't need to know that for your GCSEs. Alkali metals is group 1. What are the other options? Noble gases, that's group 0, group 8. Halogens, group 7. Transition metals is that block in the middle of the periodic table. Sorry if it's a bad connection, guys. If you're on the Kahoot, then it should be fine. The connection should be fine. I think on the YouTube is a bad connection. But on TikTok is all good. Is the connection fine on TikTok? Let me know, guys. Lucky Wombat, Amazon Otter, and Fearless Ant. You guys are smashing it. Arctic Sloth has moved up to 4th as well. Lag. You go on join and then you type the code in. The code is 4456661 if you want to join. I think it's at the bottom of the screen. You can see it at the bottom, the pin. Should be able to join. Simple molecules, simple molecular substances. They have strong covalent bonds and electrostatic all the time. The answer here, they have a covalence, and these thought that's what I thought. That's what I thought. Type of bond you can think that happens between atoms. Intermolecular happens between molecules. It happens between atoms. Intermolecular happens between molecules. How many questions? There's 17. We're on question 10. Question 10 of 17. So 7 more. 7 more. Okay, 2 more seconds. There we go. Potassium at the top, then sodium, then carbon, then copper underneath. That's the order, guys. 41 of you got that correct. Well done. Well done. What's the difference between electrostatic and intermolecular? That's another one people get confused between. Electrostatic is between something that's positively charged and negatively charged. So, for example, a positive ion and a negative ion. They get attracted by electrostatic. Intermolecular, it's in ionic bonds. You have them in metallic nucleus and the sea of delocalized electrons. You lost your answer streak. Unlucky, unlucky. Makes sense now. Good to hear, good to hear. On to the next one. Let's go. Are metallic bonds electrostatic? Yes, they are. Yes, they are. They're electrostatic between the positive electricity. Just told you the answer. Ooh. There's no moles in the paper. I think there's a few questions on moles here. Delocalized electrons. Yes, good. Well done. Most of you got that. For ionic bonding, it's not delocalized electrons. They conduct electricity because of free moving ions. But I'm happy most of you got this right. Delocalized electrons is the right answer. You're stuck at 4th. You need top 3. Keep going. Keep going. On to the next one. AQA comes up, make paper 1. On to the next one. Let's go. What is the formula to calculate moles? Here we go. Someone asked. Moles is equal to equations. You don't get an equation sheet like you do for physics. And moles equals mass over MR. Yep. Okay. Let's try. Let's see what the 3. We'll get FRL Pro free for a month, and you guys will be able to attend my cram classes. We got one on Sunday evening. But if you are in the top 3, take a screenshot, guys, and DM us, and then we can upgrade your account. Okay, Olivia, well done, you're 3rd. Keep it up. Keep it up. Question 13. What does reduction involve? Out of these ones, which one's reduction? Gain of oxygen, loss of hydrogen, loss of electrons, gain of electrons. Gain of electrons. Oil rig. Oxidation is loss of electrons. The last few are hard, I think, so people will get a chance to jump up. In the next one, we've got someone new in the top 3, I think. Prayer Rhino. Nearly done, guys. We got 4 more. Will I be doing another one? No. After this, I will go through some exam questions, guys. So stick around if you want some. Ion do acids release? Hydroxide, hydrogen, carbonate, or acid? So this one, and then we got 3 more after that. Is in them. Hydroxide is for alkalis. Alkalis release hydroxide ions, OH- ions. Really well as well, they're getting them right. Is this triple? Yeah, it can get asked in triple as well. It's not triple only. It's combined and triple. All the questions say 17. We're question 15. What is formed during neutralization? A neutralization reaction. 2 things are formed. Not reacted. Not reacted. It's asking what's formed. Prev, what happened? You clicked the wrong one. It's what's formed. Neutralization is when you get an acid and an alkali, you react them together and it forms salt and water. Unlucky. Who was lucky one back again? Was there someone in the chat? I don't know. Keep it going, guys. We've got 2 more questions. 2 more questions. where does oxidation happen? This is an and press submit, I think. So we've got two there, anode and the cathode. A difficult question, thinking question. Nice, a lot of you got that right. Oxidation happens at the anode. Oxidation at the anode, so that's the positive one. So you get to move your pin to the positive electrode. Nice, nice, nice. Okay, person in the podium, guys, email to send the screenshot to, and we can give you guys access to our cram classes. Lucky Wombat, Prayer Rhino, and Rapid Badger now has just joined. A quick, easy one. Just warning you guys now, okay? Think about this one. This came up in an actual exam. Second and third out of all of these. Move them in order, guys. Go, go, go. This came up in 2023. You had to write them down in the correct order. So this is where you need to know. This is something that could get asked. Whoever's on the podium, remember, take. Unlucky, Priv, unlucky. It's all learning experience, guys. Most important thing is the paper on Monday. There we go. Electrons got discovered first by J.J. Thomson. Then protons got discovered by Niels Bohr. And neutrons was discovered by James Chadwick. If you found that hard, I'm going to go through some questions now straight after this. So stick around. You guys can ask me questions on things you don't understand. I'll stick around for a bit longer. Well done, Lucky Wombat, Rapid Badger, Prayer Rhino. Remember, take a screenshot and DM us and we'll tell you what to do next. Forget that. Important thing is what we're going to do now. Let's do some more questions. Okay? Let's improve your a bit of fun. Right, we have a bond energy calculation. Okay? If you see these, just remember to always do, if it asks for overall energy change is equal to bonds broken minus bonds formed. Calculate the reactants and then the products, and then you subtract the two answers. Right, let's see what numbers we've got here. So what you need for this bond, purple for this and red for this. Okay, we're going to count up every bond that we've got. So let's look at the reactant side first. Reactant side, we have one OH here, we've got one OH here, right? So that's going to be 463, because that's what it says here. 463, am I in the way? Times by 2, because there's 2 of them. And then we've also got one oxygen in the middle as well. Oxygen's 138, so I'm going to add 138 to that. Okay, now we get that, and we notice that there is a 2 in front. This means you want to multiply everything in, if you're right or not. That is the reactants done. Now you need to do the products. How do you do the products? Add all of these up and then subtract. So let me get this whole thing, put it in brackets. Now let's do the products. What do we have in the products? We have 2 OHs, 1, 2, 2 OHs. So we're going to do 2 times 463. But don't forget there's a 2 in front of that. We need to multiply that by 2 again. So 2 times all of that. Now look at the other product here. What do we have? We've got oxygen here. What we're using for oxygen? We're using purple, right? So 1 oxygen here. Oxygen is 496. So we're going to add 496 to this. And let's put all of that in brackets. Brackets. Put that all in your calculator and you should get the right answer from that. Okay, so if you do put that in the calculator, you should get a negative answer. You should get minus 220, guys. You can take a screenshot and try this at in your own time if you want, guys. Practice this. What does negative mean? If you get no negative number, does anyone know what that means? If it's negative, let me know in the chat if you know. Exothermic. Negative is equal to exothermic. What does exothermic mean? Exothermic means it's on. Questions about the electrolysis. Some metals are extracted from molten compounds using electrolysis. Why is electrolysis used to extract some metals? What do you guys think the answer here is? Okay, let me know. It's not, electrolysis isn't the main process that we want to use to extract metals. The main thing we want to use is reduction. We want to use reduction by carbon. Yeah, we only use electrolysis on one condition. Does anyone know what it is? Why do we use electrolysis? We don't want to use electrolysis because it's usually we don't, because it's more expensive, right? Exactly. Lots saying it. I think you need to be a bit more specific. Yeah, so you said some metals can't be extracted from other metals. Yeah, the other method is reduction by carbon. If the metal is more reactive than carbon, we can't use this top method. We can't use reduction by carbon. Very expensive process. So we'd rather not use electrolysis, but for these metals which are more reactive, we do have to use that. So we can say metals are more reactive than carbon. So can't be reduced. Can't be reduced using it. Yep, there we go. They're stable. Don't say stable. I wouldn't say stable. Okay. Aluminium extraction. What do you guys think the answer is here? Aluminium extraction is the one specific one you need to memorize. It's the one specific one you need to memorize. Does anyone know what is in it? There's two things in it. This is what you're putting your electrodes in. No, not delocalized electrons. No. Okay. Have you guys, other thing is the actual ore. The thing we're extracting aluminium from. What are we extracting it from? We're not extracting it from aluminium. So we can't say aluminium on its own. That's not going to get us marks. Because that's what we're trying to get out of it, right? The answer is aluminium oxide. So let me explain that. Remember what the whole process of this is, okay? We are trying to extract metals. We're trying to get metals. How do we get metals? We dig up a rock called an ore. In that ore is the oxide version of that metal. So if it's aluminium, there's aluminium oxide in that rock. So we take the aluminium oxide, we melt it so that we can use electrolysis on it. The problem with melting it on its own is that it has a very high melting point. So it needs a lot of energy to melt. So what we do is we mix it with something called cryolite, which lowers its melting point and it makes it much cheaper to melt. There we go. Not a catalyst. No, it's not a catalyst. Half equation. Half equation. Those of you who come to my classes know the steps I always tell you to follow when it comes to half equation. Half equations. Ions, atoms, molecules. So check whether it's diatomic. Then balance atoms. And then balance electrons. Okay, so 2 steps. What you do is you write the ion on the left. So we're dealing with copper. So the ion of copper is Cu2+. You add the atom on the right, Cu. This is a reaction, so we're going to put an arrow in the middle. Next step, molecule. Is the molecule diatomic? Is copper diatomic? It's not, because I told you guys earlier, a diatomic molecule ends in GEN, oxygen, nitrogen, hydrogen, and halogens. Okay, so we don't need to do anything. We don't need to add like a 2. If it's diatomic, we would make this Cu2, but it's not. So we leave it as it is, Cu. Okay, then we balance the atoms. Atoms are balanced. We've got 1 copper here. We've got 1 copper here. These two are already balanced. There's nothing to do here, so that's done. And then it's balance electrons. Which side do we want to add electrons to? If it's a positive ion you're dealing with, you always add electrons on the left. If it's negative, you add electrons on the right. But you need to balance this. And we get the answer for the top one. So it's Cu2 plus 2E minus goes to form Cu. All right, let's follow the same steps now for chlorine. So first step, ion, Cl minus. Okay, on the right, we're going to write the atom, Cl. Is chlorine diatomic? Chlorine is diatomic. It's a halogen. It's diatomic. Any group 7 element is diatomic. So we need to put a 2 up here to make it Cl2. Now we need to balance the atoms. So we've got 2 chlorines on the right. So we need 2 chlorines on the left. Balance that out. 2Cl minus. Done. Now, how many do we need? Each chlorine atom is losing 1 electron. So in the end of that, we get 2 electrons, 2E minus. So the answer here is Cl2 plus 2E minus. Well done, those of you who got that. All right. Figure 1 shows the apparatus a student used to electrolyze copper chloride solution. What they did is they measured the mass of the copper deposited on the negative electrode after 60 minutes. A certain mass to be formed, and then they did the reactions, and then they compared the two, and they realized, and then they tried to check whether it was equal to the expected or there was some discrepancies. It says here, suggest 2 reasons why the mass deposited was different. So there was some discrepancies from the expected value. Why could it be different? This is actually quite a hard question. Have happened in the experiment. So remember what you're doing. It's not to do with gases, no, because there's no gas here. We're measuring the mass of it, and we're seeing, has the mass changed? This is electrolysis, so it's probably still not incomplete. They've taken it out of 60 minutes. After 60 minutes, we don't know if it's complete or not. Reaction's not going to happen at 100%. And there probably will be impurities in there, even like a few atoms. The other thing, another thing, this is in the osmosis practical on bio actually. You know, with the potato cylinders, when you're measuring the mass of it, what do you need to remember to do? You need to do the same with the electrodes here. Foundational higher, this is, I think this is a higher question. I think the earlier ones, higher questions there. Back to my question, guys. What do you need to do to the electrode? Make sure they're clean, not clean. You've just taken them out of a solution, right? So what's going to happen is they're going to be wet. You want to remove that water, because why there was different was because it wasn't dry. Were not impurities. No, they're not asking you what to do. They're just asking why is there a discrepancy. No, strange. Use new electrode. It's not asking you what to do. It's asking you why. Why is the expected value different? Determine the expected time. They want us to determine, so that means figure out, expected mass after 24 hours. Any ideas what we can do here, guys? Let me know. There's a calculation question. It's one of those application questions. So we've got no. So what you can do here is you can 5.5 times 48. No need to use 48 there. So go to 30 minutes. 30 minutes is a good number to go to. So you basically find out how much mass has been produced after 30 minutes. We know that's half an hour. And what we can do is we can find out what 1 hour is by timesing by 2, and then find out what 24 hours is, because that's what the question's asking, by timesing it by 24. Okay, so you don't need to find the gradient here. What you need to do, go to 30 minutes, get a ruler, draw a straight line up, and then read off what this is. Okay, I'd say it's around there. Find out the amount for 30. We've got around here. Let me draw this a bit better. That's not the best line. Let's look at this carefully. It's on this around the second small box, isn't it? Okay, so if we read that, what do you guys think? You don't need to use y equals mx plus c here. No, you don't. You won't get expected to do that in GCSE. That's 5.4. Yeah, well done, guys. 30 minutes, we'll say 0.5 hours. Okay, what do we want to do? We can work out what it is after 1 hour by timesing it by 2. So we'll times this by 2. And then to work out what it is in 24 hours, you times it again by 24. So we'll get this and times it by 24. So what we're essentially doing is 5.4 times 2 times 24. And that will give us our final answer. There we go. In the chat, we've got it. Well done, guys. 259 milligrams. 259 milligrams. Is electrolyzed. Figure 3 shows the change in mass of a negative electrode over 10 hours. Determine the mass of the negative electrode at the start of the experiment. This one sounds complicated. It's not. It's just reading off the graph, isn't it? If you read it as 5.5 but the same method, you get the mark. Yeah, you would. It's 5.4, 5.5 is fine. It wasn't exactly 5.4 anyway. So it's fine if you don't. I think that point is, how long am I live for? I'm gonna jump off soon, guys. What is it? 10. It's getting pretty late. I'm getting tired. I'm sure you guys are tired. A lot of revision to be done. Got a few more videos that I'll release. 7.5, not 4.95. Okay, so be careful there. Look at the scale. Let's look at the scale. 2, 3, 4. Okay, so that is 4.75. It's 3/4 of the way between 4 and 5. So that's 4.75. Calculate the gradient of the line. How do we calculate gradient, guys? Change in y over change in x. Let's give that a shot. So we just read that that was 4.75. So let's go from that. Let's make a triangle. Go all the way across. And then all the way up. Okay, so remember what I said. I said every 1 square is 1, right? So this is 1. We need to find out the change in y with change in x. Change in y is very straightforward because it's going from here to here. We can read that from our graph, 0 to 10. That is 10. We need to know what the change in y here is. So what's the height of this? 1, 2, 3, 4. Around 4 squares. Remember, every 2 squares is 1. So that is a 2 there. Yeah, you can do that as well. 2.5. It's a bit hard to read, right? So gradient of the line, you would do that. And you would do change in y. So 2 divided by 10, which gives you 0.2. Questions asking for units, guys. What's the units here? What are the units here? It's change in y over change in x. This is our y. This is the x. What's next? I think I'll make this the last question, guys. Change in y over change in x. Any ideas? Grams per hour. Exactly. Grams per hour is the answer. The way you figure it out is this is your y. Y is 2 grams, right? 2 grams, 10 hours. 2 grams over 10 hours. So that's 2 over 10, which is 0.2. Grams over hours, which is grams per hour. So unit is grams per hour. You were expected to figure that out from the question. Yeah, it has to be hours, not seconds, guys. Hope Monday morning goes well. I'll post a few more questions. Sorry, a few more videos. And with this paper itself, I'll let you guys download this. I'm going to go through all the questions on it. Okay. One more question, last question. Go on. Tell me what you think the answer here is. And then I'll shoot off. Any other last minute questions before chemistry, guys? I'm not gonna be on TikTok before chemistry. I'll try and come before physics. When's physics? Physics on Thursday, right? Got cram class on Wednesday, the only other day. Though everyone's gonna be in the middle of exams. What's between chemistry and physics? Are there any core subjects? Is there any English or maths between them? Let me know. And then I can plan because there's no point doing a Kahoot like the day before, like an English exam or a maths exam. Everyone's going to be revising those, right? I don't want to distract you guys. Answer here. That's the third one. Yeah, you guys are right. Third one. English lit. When's English lit? Last English lit, and then you're done. Then you're done with the English lit for good, unless you do it for A levels. Okay, yeah. English lit, is that on Tuesday or is it on Wednesday? So many core exams next week. Is there on TikTok? Maybe we can try that. And then on Wednesday we'll do the normal cram classes. And you guys can join that using the link on our bio as well. All right, guys, it's been a pleasure. Good luck for Monday. I hope it goes well. And yeah, I'll try and see you guys on Tuesday, and I'll try to do a similar thing to today. Good luck, guys. Have a good evening. Go get some rest. Get some revision done next 2 days as well. And then you got a week, and then it's half term, so you got not a break, but like at least you don't need to do any exams. You can just bang out some more revision during there, right? Okay, have a good evening, guys. I'll see you next week. Bye.